Okay, fine. And then we have the advanced reduction operations. Fine, there are two advanced reduction operations available. Okay, one is reduce and the other one not mentioned there. I'll just show that. What are those two things? So these are the two advanced reduction operations. Let me just check that. Yeah, there are two other methods. One is this method called reduce. I'm just only giving the method name. And other is the method called collect. Interesting methods, because we do this all the time. We have been doing it. Initially, as you start learning, the first things, some of the first exercises you might have done would be the reduce exercise. Finding the sum. Yeah, you do finding of sum. It's a reduce operation. Sum of all the elements in an array, right? Similar. So what do we do in that when we have to find sum? You have a starting value. That's your identity value. Then what do we do next? We have some starting value of 0, right? If I have to find sum, my identity would be 0. Then what's the next? Oh, we do the plus operation. My function is to add. See, one is identity, other is the add function. And this is what I have to do with every element. Fine. My previous value is the identity initially. The result of applying from the first element from my stream, I need a function, I need a unary operator. Reduce method, let me talk of the reduce method, okay. Reduce method takes as parameter a value of type t, which is nothing but your identity. And second thing which it is taking is a binary operator, unary operator, sorry. No, it's a binary. Yeah, it's a binary operator. Second is nothing but a binary operator of t. So that's a binary operator. And what it gives me is the value of type t. Identity 0. What is the operator I am giving? Add operator to get the sum. To get product, identity 1, multiplication. Identity has to be accordingly, right? Fine. So one very simple reduce method is like this. The actually overloading done for reduce method. There are two more forms of reduce. Okay, we may have to look at some of those miscellaneous classes. One of the class is the class called optional. We have one of the class called optional. Okay, that may be useful because we have one, we even have a reduce method which is like this. Let me show the other reduce method. So the reduce method, it says you can give me a binary operator only. That's also fine. If you give me the binary operator, you have not given me the identity. What do I use as the identity? The first element. No, the first element from my stream. The first element from my stream.
Depending upon binary operator, we have to set the first element. If we have
That's the first case. If I'm passing a first element, I'm not passing a first element. I'm saying, okay, I have to do addition only. Okay, fine. I'll just keep on adding, but I need some starting point. So whatever I'll get as the first element will be considered as the starting point. I'll consider that as a starting point. Fine, I'll use that as my identity. But then what if that is 0? There are no elements in my string. What happens in that case? When I give identity, at least it can return the identity value itself. If this string was empty, if the string was empty, the identity is returned. But what in this case, in the second case, what will it give me? I have not yet mentioned the return type, therefore. It doesn't give you, the return type is not t, though it will give you the value of type t, but not directly. We have a class in the java.util package called optional of t. We have the class called optional of t. It's in the java.util package.
So it will not return
it returns this. So how do I look at optional? Optional of t. So optional is just like some box which may be empty or it may have at the most one element. That element can only be of type t. So we don't have null, but we have optional. Optional may not have a value. You'll get optional, it won't return null. This method would not return a null. It would give you an object. That object will be of type optional. You can check in this optional, is it empty? Does it have a value? If it's having a value, I have a get method to get the value. On optional, I call the get method to get the t.
So at least it will not throw null pointer exception.
Not null pointer exception. And because I might do reduce dot something. Oh, if I say reduce dot something, if reduce was returning a null, I'll get a null pointer exception there. No, but when I say reduce, and if I don't do anything, if I try to do something directly on reduce, no, I can't. I'll have to use method of optional. It always reminds me, oh, this is something which can be null. See, it immediately reminds to the one who is using that optional that, oh, you are not getting the value directly. You have to still go further to fetch it. Reminder can be null. Check for empty. Fine. If it's not empty, get it. And so we have this class optional.
Throw an exception which we will have to take care of, or
No, it doesn't throw.
us and not get compile at all. So
now what would you do? Now, as you write your code, right? When you write your code, you'll say reduce, right? And if you have used this form of a reduce, what's the next operation you can perform now? What's the type? Optional. You can only use method of optional. And if you are using an ID, if you say dot, fine, you are forced to use a get method. Fine. Now, if you are using get method, you actually, because you don't get the value here itself, you get reminded that there is something. This may be empty. Fine. So you can say dot. You could say there are various methods available. For example, you might even say if it is existing, then do this. It could be like this. If it is not empty, then I'll perform some consumer. You have a consumer, int consumer. Find consumer of t. It's an optional of t. It has a method called if exist or something like that. Exact method name I don't recollect, but something where it will do the testing for you, and if it is existing, only then I'll take the action of whatever you give me as a consumer.
So we need to do additional condition. check it.
Yeah, you will be forced to basically. You get reminded about it.
Yes.
Oh, that is the difference. Actually,
You get reminded. Otherwise, you won't care. You might just be thinking, you are not thinking that this may be null. But this makes you think that this can be null. It's an immediate reminder. There's something which can go null. If you start putting a get straight away, you are asking for a null pointer exception on your own.
Yes.
You're asking for a null pointer exception. The get method will throw the exception. The get itself would throw an exception.
that's why check exceptions are very useful. The program will not get compiled at all. So why is the question of any exception situation? But here, while writing code itself, you are taken.
Yes.